This conference will now be recorded.
Good evening, students. We have been discussing numerical problems from JEE and JEE Mains paper 6th September 2020. So today we'll be finishing this paper, and next class onwards we'll catch up with different paper. So let us solve the questions specified for today. So the first question, as you see, this is question number 1 for today's session. Suppose the intensity of a laser, I'm sorry, this, I think this is fourth question, sorry. Yeah, so the first question is this one. An AC circuit has R resistance 100 ohm, capacitance 2 microfarad, and inductor of inductance 80 millihenry, and these are all connected in series. The quality factor of the circuit. So this is actually numeric type question, section B. Here we have to write the answer nearest, like with integer, non-negative integer number. So this is really memory based question. If you remember the definition of quality factor, then only you will be able to answer the question. So just for your sake, like, see, this quality factor Q is given by omega 0 L by R. This is actually the quality factor. What is omega 0? Omega 0 means resonance frequency. Resonance frequency. So what is the expression for the resonance frequency? That is 1 over root over L into C. We all know this. So if we write this omega 0 here in this expression as root over 1, okay, so 1 over root over LC, then look what we get. We get 1 over R root over L by C. So this is the expression for the quality factor. So you know this L and C are given and R also is given. So what is quality factor? Let us write down 1 over 100 into root over L by C. L is 80 millihenry and C is 2 into 10 to the power minus 6 farad. Okay, so this will be becoming a unitless quantity. Quality factor, this is a number actually. Okay, look, then we have here 100 and here it will be 4 10 to the power minus, sorry, 10 to the power 4. Okay, so you get 2 into 10 in the numerator and 10 in the denominator, so it will be having value 2. I'm sorry, this is actually, okay, so this is not numeric type question. There was options. Okay, there were options. So we have few questions numeric types. So this is the question which is numeric type, so we have to answer this question in integer number. So here this was actually, here there was like there were options given, so we had got the option C correct here. Let us go to the next problem. So this problem says initially a gas of a diatomic molecules is contained in a cylinder of volume V1, pressure at pressure P1 and temperature T1. Okay, assuming 25% of molecules get dissociated, causing a change in the number of moles. The pressure resulting gas at temperature 2000 Kelvin when contained in a volume 2V1 is given by P2. What is the ratio of P2 by P1? Look, I have a container. Initially, suppose I had the whole thing I can take as a 1%. So it was actually at temperature. Initially, it was a diatomic molecule. Okay, suppose there were n moles. Okay, initially n moles of the atomic gas is there. Okay, and it is at temperature T1, volume V1 and pressure. Okay, temperature T1 is given 250 Kelvin. Now when it get dissociated, then what we have suppose 25% molecules have dissociated. Okay, so what we can write the total number of moles for that. So the number of mole n prime will be 0.75 n0 plus 0.5 n0. See, 25% of molecules are dissociated. Okay, 25% of molecules dissociated. Okay, so the remaining is 75%, which has this one moles n0, and see the number 25% we have got here, which got dissociated, will provide a 0.5 into n0 number of moles. Okay, so this is the new moles or new number of moles. So this will be actually 1.25 n0. Okay, now look what I can write. I can write P1 V1 is equal to N1 RT, where N1 is N0. Okay, RT1. Similarly, I can write P2 V2 is equal to the new P2 V2 is equal to N prime R T2. Okay, look now, if I take the ratio of this, I have to actually write. So P2 V2, I'm taking this ratio P2 V2 by P1 V1 is equal to N prime RT2 divided by N0 RT1. Look now, this P2 is given here. Okay, sorry, P2 I don't know. V is given as 2V1. Okay, so V2 is given as 2V1, double of the volume, 2V1 V2, and T2 is given as actually 2000 Kelvin. Now we have to find out this ratio. Look what I get, 2 P2 V1 by P1 V1 is equal to N prime. N prime we have got as 1.25 N0. Okay, I think better to go in the next page. So I have got P2, V2 is 2V1 divided by P1 into V1 is equal to N prime RT2. Okay, so N prime is N0 into 1.25 N0, R T2 is 2000 Kelvin divided by N0 R T1. T1 is actually 250 Kelvin. Okay, so this R0 N0 goes up, this goes up, so I get P2 by P1 is equal to 1.25 into 2000 divided by 2 into 250. So you look, I get this, here it is 100 and this is 0.5. Okay, 0.5. So this is actually 50. Let me cross check once again. 2000, this is whether 250 Kelvin, fine. 2000 to be okay. Things are all right. Okay, let me check here. Okay, so I'll just redo the calculation here. I think I should get 5. Let me just check here. All the problems are here. So 1.25 into 200, sorry, 2000. Then you have 250 into NR N0R. Okay, N0R T. Okay, fine. So okay, 1 2 is here, so 2 is here, so I have to multiply 2 here. Oh, sorry. So this goes like this. So here I have to multiply 100, say. So this 100 will cancel each other. This is 5 and this is 1. Okay, so this is actually 5. P2 by P1 is equal to 5. Now let us see this problem. This is a very interesting problem. This problem says a part of a complete circuit is shown in this figure. A part of a complete circuit. This is a part of a complete circuit. Is shown in the figure. At some instant, the value of current I is 1 ampere, as you see. So current will be 1 ampere in this at any instant, and it is decreasing at rate. So di dt with a minus sign, decreasing rate, 10 to the power minus 2, sorry, 10 to the power 2 ampere per second. It is decreasing. Okay, the value of the potential Vp and Vq is how much? So look here, in this case you have to find out potential difference Vp and Vq. So I need to know what is the potential here, what is the potential here. Okay, and the battery is also there in between. So what to do with that? Let us discuss that thing. See, so as the current changes, there will be back EMF produced here. Okay, back EMF produced here. So that's why it will also act as a actually battery. Okay, at any instant of time when the current is changing, so it will actually act as a source or battery which will provide EMF of L minus L di dt. Okay, now here Vp minus Vq I have to find out. Look at what we can write actually. Vq I can write, since current is flowing this way, I can say this is at higher potential, so Q minus IR. IR means 1 into R. This ohm, see this R is actually 2, so it will be 2 ohm. Okay, so 2 ohm, and obviously you have this 30 volt, and this L di dt I have to multiply. L is 50 into 10 to the power minus 3. Di dt is 10 to the power 2 again. So this is equal to Vp. Okay, so I have to find out Vq, sorry, Vp minus Vq. Vp minus Vq then will be, this is 2, so this is 28, and this you are going to get here. So this is 5 and this is 28. So in volt it will be actually 33. Okay, this will be 33. So this is the answer for this question. Okay, so here one point you have to remember, that the direction of the current is given. That means this is at higher potential, and all over there will be drop in the potential. Okay, there will be drop in the potential. So Vq minus, that's why I have written Vq minus 2 volt here, and then you have this battery with a positive sign, obviously, because current is just going out from the positive terminal, and then you have back EMF over here. So here also you look, this side current is flowing in this way, so you can take this as a positive source. So in that way, if you go, so all this will actually add up to Vp. Okay, so this is how we can solve this kind of problem. Now let us go to the last problem for today's session. So this last problem says, okay, this is saying that suppose the intensity of a laser is 315 so intensity is 315. I think this is 315 over pi. 315 over pi. Okay, watt per meter square. The RMS electric field in unit volt per meter associated with this source is close to excuse me, close to the nearest integer dash. Okay, so here you look, intensity of the excuse me, laser light is given, so that is 315 over pi watt per meter square. Okay, this is actually the intensity. And you know this intensity of light is related to the energy density by this way. I is equal to U energy density into C. So this energy density can be written in terms of magnetic field or electric field, where C is the speed of light. Okay, you can write in any way. So let us say this is electric energy density, since I have to find out electric field. So I know electric energy density will be half epsilon naught E naught square into C. So E naught will be 2 into I divided by epsilon naught into C and square root of that. So you can put the values. 2 into I is 315 over pi I can write here into epsilon naught C. So look what I can do. C, I can just put the values directly. C is 3 into 10 to the power 8 meter per second. Okay, so here if I multiply 4 in the numerator and denominator, so I can put this value instead of writing this all these values here. So 9 into 10 to the power 9 I can write. Okay, then 315 into 4 divided by this part 3 into 10 to the power 8. Okay, so this will actually give you here 10. This will give you 3 here. Now you multiply this 315 with 12. So what you get? So this is what you get. And you know, if you okay, so you have to simplify it properly. And upon simplification, I hope all the points, all the numbers I have written here correctly. So if you do the calculation, so this is the way to do. So what is the main point here is that you need to remember the relation between intensity and energy density. That is the main point. This is also memory based question only, so you have to remember this relation. I is equal to UC, that you have to remember, otherwise nothing was there. Okay, rest of the thing is calculation. So I hope you can do better than me. Okay, so it will actually be 194 to the nearest integer. Okay, so now I think there is one more problem here to solve, then we'll complete this 6th September paper, first shift. Second shift will be catching tomorrow. So this question says two bodies of the same mass are moving with same speed in different directions in a plane. Let us say, and see they have a completely inelastic collision and move together thereafter with final speed which is half of their initial speed. I'm just thinking, this is suppose horizontal line and one particle is moving, say two bodies, one body having mass m1 is moving with velocity v making an angle theta, another one is also moving with the same speed but the direction is different. Okay, I'm just taking the direction like this, otherwise how do you get, like they're moving also with same speed So speed will be same, this vector also will be the same, and they will actually make a collision, okay, or they will make a collision V with the same, okay. So you look here, this is nothing but conservation of angular momentum, and see they suppose they are moving after collision together with this, okay, in this direction together. Now it is moving together. So initial momentum is how much? That is mv cos of theta into 2, and final momentum is 2m. They are moving together with half of the initial velocity v by 2. So the question is the angle between the initial velocities of the two bodies in degree, so that you have to find out. So look, I can just equate them. So conservation of linear momentum, so this will be 2mv cos of theta is equal to mv, okay. So mv goes off, cos theta is equal to half. So cos theta is equal to half. This implies that theta is equal to 60 degree, okay. So this theta is 60 degree, this theta is again 60 degree. So what will be the angle between the initial velocities? Therefore angle between the initial velocities is 2 theta, which is 120 degree. So this is actually the answer for this question. So this will be in degree, so 120 here, okay. So with this we will actually stop it here for today, because I don't have any more questions from this paper. We'll next day we'll take the, this is actually shift 1. We had discussed the question, most of the questions from shift 1. So tomorrow onwards we'll start with shift 2, okay. 6th September shift 2, okay. So thank you for your patience. Bye for today.